Hi everyone, welcome to today's class, which, trust me, you are going to find super duper insightful, because today we will discuss about some very useful hacks, tricks and shortcuts through which you can very easily crack the questions of trigonometry. So without any further delay, let's quickly get started. The very first question is this one. It is asking us to compute the value of the expression which is the product of tan 1 degrees, tan 2 degrees and so on till tan 89 degrees. What is the value of this product out of the given options A, B, C and D? Well, first of all, realize that here we have the product of 89 terms, isn't it? And 89 is an odd number. So can you tell me what will be the middle term here in this entire product? Well, if I talk about the middle term, it will be 89 plus 1 by 2th term, which means 45th term. Correct? Easy peasy. If you have number of terms as n, and if n is odd, then n plus 1 by 2th term happens to be the single most middle term sitting in that expression. Alrighty. Now, if the first term here is tan 1 degrees, second term is tan 2 degrees and so on, obviously 45th term will be tan of 45 degrees. So this means that I can write my product, my original expression as tan 1 degrees into tan 2 degrees into and so on till tan 44 degrees. So these are my 44 initial terms from the beginning. Then you will have the 45th term which is sitting in the middle, that is tan 45 degrees. And then you have the latter 44 terms. So you have tan 46 degrees into and so on till tan 88 degrees and then tan 89 degrees. These are again 44 terms. Now, tan 89 is nothing but tan of 90 minus 1. And tan 90 minus theta is nothing but cot theta. So first term from the beginning is tan 1 degrees. First term from the end is cot 1 degrees. Second term from the beginning is tan 2 degrees, you can see. Second term from the end is tan 88 degrees, which again is what? It is same as cot 2 degrees. Why? Because 88 and 2, their sum is 90. Again, they are forming a pair of complementary angles. So tan 88 is same as tan of 90 minus 2, which is same as cot 2. Third term from the beginning will be tan 3 degrees. Third term from the end will be tan 87 degrees, which is same as cot of 3 degrees. And so on. 44th term from the beginning is tan 44. 44th term from the end is tan 46, which is same as cot 44. So what are you getting? You are getting the product of first term from the beginning and first term from the end as tan 1 into cot 1. Then product of second term from the beginning and second term from the end, which is tan 2 into cot 2. Similarly, third term from the beginning, third term from the end will be tan 3 into cot 3 and so on. 44th term from the beginning into 44th term from the end will be tan 44 times cot 44. So we have 44 such brackets, individual brackets, and you have the last 45th term as tan 45 degrees. Now you can clearly recall the hack, the trick, the shortcut, the identity, the property that tan and cot are actually reciprocals of each other. And all the angles involved here are acute angles. Can you see that? All the angles, all the arguments sitting here are less than 90. Whenever the angle is acute, each trigonometric ratio is positive. So it is safe for me to write cot of 1 degree as 1 upon tan of 1 degree, and because tan of 1 degree is definitely positive, I will be cancelling it out. Similarly, tan 2 into cot 2 will be 1. Similarly, tan 3 into cot 3 will be 1 and so on. Tan 44 into cot 44 again 1, and tan 45 you already know is 1. So you have product of 1 with itself 45 times in total, which is nothing but 1 only. So originally the expression looked pretty complicated, but then we started clubbing the arguments after observing the complementary angle pattern between them. And that's when tan and cot are complementary functions of each other came into our minds. And that's when the hack came into action that tan into cot is 1 because they are reciprocals of each other. Also, when I say tan and cot are complementary functions, that means at complementary angles, they give the same answer. So whatever is tan 90 minus theta, same as cot theta. Whatever is tan theta, same as cot 90 minus theta. Okie dokie. So we have A as the right option here. This was quite a simple question and we've just used 2 results to actually crack it. One is tan theta into cot theta is 1. Other is that tan and cot are complementary functions of each other. This one says that if 1 plus tan 1 degree multiplied by 1 plus tan 2 degree multiplied by 1 plus tan 3 degree and so on till 1 plus tan 45 degrees is 2 to the power n, what is n equal to? Well, first of all, again I want you to observe this big fat product expression. What is happening here? You have 45 individual brackets which are being multiplied. So I can say that the first bracket is acting like the first term, second bracket is acting like the second term, third bracket is acting like the third term and so on. 45th bracket is acting like the 45th term. So here again, just like the first question, you have product of a lot of terms. How many? 45. What will be the middle term? Again, 45 is odd. So 45 plus 1 by 2, right? So 46 by 2, that means 23rd term will be the middle term. Correct? Okay, but do we need that over here in this question? Let's see. Let me write a few terms here and then I'm going to discuss this further with you. So you have 1 plus tan 1 degree multiplied by 1 plus tan 2 degree and so on. Then you have 1 plus tan 22 degrees. Then you will have the middle term, which is the 23rd term, which will be 1 plus tan 23 degrees. And then you will have the latter 22 terms. So 1 plus tan 24 degrees and so on. 1 plus tan 44 degrees. 1 plus tan 45 degrees. Okay? Okay? Now what? Well, please catch hold of the look of each bracket. It is of the form 1 plus tan theta, which should immediately remind you of the fabulous result that whenever A plus B is 45 degrees, the product of 1 plus tan A and 1 plus tan B is nothing but equal to 2 each and every time. Whenever the sum of two angles is 45 degrees, 1 plus tan ratio of the first angle multiplied by 1 plus tan ratio of the second angle always results in 2 as the answer. Here, let's try to make pairs of angles whose sum is 45 degrees and see if this result can somehow come into action. I know 1 degree and 44 degree. They will add up to give me 45. So you have 1 plus tan 1, 1 plus tan 44, right? 1 plus tan 1 into 1 plus tan 44. Correct. Okay. This is one single entity. Right? It is resembling 1 plus tan A times 1 plus tan B, where A plus B is 45. Okay. So last term from the beginning was 1 plus tan 45. That is untouched for now. I am taking first term from the beginning and second term from the end, isn't it? Right? For a second, just to avoid confusion, if you ignore 1 plus tan 45 just for a while, just for temporary basis, you have 44 terms in total, right? So now just concentrate on these 44 terms from 1 plus tan 1 degree to 1 plus tan 44 degrees. And now see that first term from the beginning and first term from the end, they will get combined together because the sum of their angles is 45. Similarly, second term from the beginning is 1 plus tan 2 degrees. And second term from the end will be 1 plus tan 43 degrees. Again, you can see 43 plus 2 is 45. So you have 44 terms in total, right? After we have ignored the last term, 44 terms. First term from the beginning, first term from the end, creating a particular pair. Second term from the beginning, second term from the end, creating a particular pair. So if you have 44 terms, you will have 22 pairs, exactly half, right? So you will have 22 pairs like this, 22 pairs. And in the end, you will have 1 plus tan 45. So in this question, there was not much need to actually work upon computing the middle term right in the beginning, because that is not playing any significant role here. The only observation that you had to keep in mind was that you have to ignore the last term for a while, so that you are left with a product of 44 terms, which is an even number, and you are clubbing the first term from the end, first term from the beginning, second term from the end, second term from the beginning. Very beautifully, they're getting clubbed together and creating pairs, thereby resulting in exactly half, 22 pairs. So 22 pairs multiplied by the last term, which is 1 plus tan 45. Okay, correct? Now see, 1 plus tan A times 1 plus tan B is 2 when A plus B is 45. So here A plus B is definitely 45. That means this complete first pair is going to be equal to 2. Second pair again 2. Third pair again 2. And the 22nd pair again 2. So you will have 2 into 2 into 2, 22 times multiplied by 1 plus tan 45. Tan 45 is nothing but 1, so 1 plus 1, 2. So you are actually getting 2 to the power 23 as the final value of your original given product expression. But it is given in the question to be 2 to the power n. When you equate both these values, obviously you get the value of n to be 23. Okay, the value of n is 23, sitting in option B. So in this question, the hack, the very result which came into action to help you and to smoothen the process of solving this question was this. If you are aware of it, great. If you are not, please note it down somewhere, because it really helps reduce the number of steps to reach the answer. How do you get this? It's very, very simple. Well, A plus B is 45 degrees. Use the formula for tan of A plus B. It is tan A plus tan B upon 1 minus tan A tan B. That's it. Now, because A plus B is 45 degrees, tan of 45 degrees is 1. So, you get what? 1 minus tan A tan B is equal to tan A plus tan B. Right? 1 is equal to tan A plus tan B plus tan A tan B. What is this? What is this? 1 plus tan A plus tan B plus tan A tan B. I am going to add a 1 here, add a 1 here. What is my right hand side? It is 1 plus tan A into 1 plus tan B. Correct? And this is 2. Hence proved. So right hand side expression automatically became 1 plus tan A times 1 plus tan B, and as a result the left hand side became 2, thereby justifying the result. Alright. Now let's move ahead and talk about the next question. Okay, so here the question is saying that if sec A plus tan A multiplied by sec B plus tan B multiplied by sec C plus tan C is same as sec A minus tan A into sec B minus tan B into sec C minus tan C, then what is each side equal to, the left hand side and the right hand side of this complete expression? Now it's given to you that LHS is equal to RHS. So this equation is already holding true. I want to find out what exactly is the precise value for which LHS is equal to RHS. Correct? Okay. Now in such questions, carefully look at the equation given to you and understand, in such questions what you do is that you multiply both sides of the equation by either the left hand side expression complete or the complete right hand side expression. So I'm going to choose to multiply with this, the right hand side expression. Multiply both sides by sec A minus tan A into sec B minus tan B into sec C minus tan C. so that you end up getting sec A plus tan A into sec B minus tan B on the left, which is same as sec square A minus tan square A, which you all know is 1. Next will be sec B plus tan B multiplied by sec B minus tan B, which will be sec square B minus tan square B, again 1. And sec ratio of angle C plus tan ratio of angle C multiplied by sec of angle C minus tan of angle C. Again it will be what? X plus y into x minus y is x square minus y square. So sec square C minus tan square C, again 1. This is the situation on the left hand side. What about the right hand side? It will be the square of this entire thing, right? Sec A minus tan A multiplied by sec B minus tan B multiplied by sec of angle C minus tan of angle C, and all of this whole square. Left hand side obviously is 1. Right hand side is square of some real quantity. Square of some real quantity is 1 if and only if that real number is either plus 1 or minus 1. That means sec A minus tan A into sec B minus tan B into sec C minus tan C will be either plus 1 or minus 1. Right? But this complete expression is equal to the left hand side expression given in the question, which is this. So the value of right hand side is coming out to be either plus 1 or minus 1, and it is equal to the left hand side expression. Even that will have value as plus 1 or minus 1. So that means if the given LHS is equal to the given RHS, then both of them will be equal to either 1 each or minus 1 each. That's why A and B both are correct. But what you have to take away from this question is that I had sec A plus tan A in picture. I realize that somehow if I will get sec A minus tan A, what will get created? Sec square A minus tan square A, which will actually reduce my expression down to just 1. And how to bring sec A minus tan A in picture? It is already sitting on the right. Similarly, sec B minus tan B already sitting on the right. Similarly, sec of angle C minus tan of angle C already sitting on the right. So multiply the complete equation both sides by the right hand side expression. And that's it, you will be done. After that, the question is a cakewalk, isn't it? Moving ahead to the next question, it says, what is the minimum value of this entire joint expression provided x comes from the interval closed at 0, open at pi by 2. Let's see. Of course, I will be interested first of all in simplifying this expression as much as I can, right? As much as I can. So I can see the numerator. It is sine cube x plus 3 sine square x. यहाँ पे मुझे समझ आ रहा है कि somewhere maybe a plus b whole cube का कुछ apply हो सकता है. So let's see. I have sine cube x plus 3 sine square x plus 3 sine x plus 2 I can write as 1 plus 1 plus cos cube x whole upon cos x into 1 plus sine x. Now can I write this as 1 plus sine x whole cube? I have 1, that is 1 cube, plus sine cube x plus 3 sine x plus 3 sine square x. So these 4 terms actually get combined together to give me 1 plus sine x whole cube. Apart from that, I am left with 1 plus cos cube x and all of this upon the denominator. Let us distribute the denominator. So here you will get cos x into 1 plus sine x, 1 upon cos x into 1 plus sine x, and cos cube x upon cos x into 1 plus sine x. Alright. Now 1 plus sine x cancels out. What are you left with? 1 plus sine x whole square upon cos x plus 1 upon cos x into 1 plus sine x plus cos cube x, and this cos x get cancelled out. You are left with 2 cos x, so cos square x upon 1 plus sine x. Now I want the minimum value. Whenever I need the minimum value, what comes into mind immediately is the Amgm inequality? Because Amgm inequality says that whenever you have non-negative quantities in picture, not positive, rather non-negative, that means they should be greater than or equal to 0, then their arithmetic mean is always greater than or equal to the geometric mean. So if on the left hand side I somehow create my expression whose minimum value I want to compute, and on the right hand side I get some number, what will I get? That the expression is greater than or equal to that number. That means the expression is at least that number. So that number is the minimum value of my expression. That's how AM greater than or equal to GM helps us to get the minimum value of a particular expression. Here what's happening is, this completely is the expression whose minimum value I'm interested in computing. Let's say this is the first term, clearly it is non-negative. Let's say this is the second term, again clearly non-negative. Let's say this is the third term, again clearly non-negative. Why am I so sure it's non-negative? Because I was given in the question that the angle should compulsorily come from the interval closed at 0, open at pi by 2. So all the angles are actually acute angles. Even if x comes out to be 0, cos x will be 1, not 0. Here also cos x will be 1, and 1 plus sin x will again be 1 if x is 0. So denominator will be positive, right? Numerator here is already positive, it is 1. Similarly, if you have x to be 0 or any angle between 0 and pi by 2, the third quantity also is always positive. So all the three quantities here whose sum is my expression are individually non-negative. And for non-negative quantities, I can apply the Amgm inequality. It says that arithmetic mean of these three quantities, matlab ki first term plus second term plus third term upon 3. Arithmetic mean, the average, is greater than or equal to the geometric mean. Means first term multiplied by second term multiplied by third term raised to the power 1 by 3. Right? First term kya tha hamara? Let's quickly recall. 1 plus sin x whole square. 1 plus sin x whole square upon cos x. This is upon cos x. Plus, what is the second term? 1 upon cos x multiplied by 1 plus sin x. And third term was, let's quickly see, cos square x upon 1 plus sin x. Okay. Cos square x upon 1 plus sin x. All of this upon 3 is greater than or equal to their product. So you will have 1 plus sin x whole square upon cos x multiplied by 1 upon cos x into 1 plus sin x multiplied by cos square x upon 1 plus sin x. All of this to the power 1 by 3. Now carefully observe, 1 plus sin x and 1 plus sin x whole square cancels out. Cos x and cos square cancels out. You are left with 1 to the power 1 by 3, which is 1. So your original expression upon 3 is greater than or equal to 1, which means your expression is greater than or equal to 3. For every x coming from the given interval. That means your original expression is at least 3, minimum 3. So 3 is the minimum value of the given big fat expression. The one thing which you must not ignore and you must not underestimate is that your Amgm inequality holds true only for non-negative quantities. Because the angle was coming from this interval, that is what gave me confidence that okay, first quantity, second quantity and the third quantity, all these three are non-negative individually, and that's why I can go ahead and apply my Amgm inequality over here to further proceed. Got it? Okay, time for the next question. Here it says solve for x. So you are given an equation and you have to solve it for x. What are the possible real values of x which can satisfy this equation is what we have to find out. इस सवाल में जो result use होगा काफी intuitive भी है, but let me just show it to you, is this one. It's such a beautiful hack, it is such a beautiful property, such a beautiful result which can help you solve the question in a jiffy. It says if a cube plus b cube plus c cube minus 3abc is 0 for some abc 3 quantities, then either the sum of A, B and C will be 0 or A, B and C will be identical. Either of the two conclusions is going to hold true, nothing else. So hypothesis is that A cube plus B cube plus C cube minus 3ABC should be 0. Once this hypothesis is met, then as a conclusion, you will have either the first situation holding true or the second situation. Right? Let's start here. I have 8. 8 is nothing but 2 cube. Then I have minus sine cube x. I can write it as plus of minus sine x whole cube. So A cube plus B cube situation is created. Then I have cos cube x. I will write it as cos x whole cube. So this is like A cube, this is like B cube, this is like C cube. I just need minus 3ABC. So minus, what do I have? 3 sine 2x left, right? This is 3 times 2 sine x cos x, isn't it? So this is actually 6 times sine x cos x. Let's see if it can be written as in the form of minus 3ABC. So minus 3a is 2, b is minus sine x and c is cos x. Just solve this expression. You will get plus 6 sine x cos x, which is exactly what the remaining term is equal to. That means I have been successful in rewriting my given expression in the look of a cube plus b cube plus c cube minus 3abc. And this expression is given to be equal to 0. That means this is also equal to 0. So what are you getting? You are getting that a cube plus b cube plus c cube minus 3abc is equal to a big fat 0, which implies from the result that how are ABC connected? Either a plus b plus c is 0, that means 2 minus sine x plus cos x is 0, or a is equal to b is equal to c, that means 2 is equal to minus sine x is equal to cos x. So I have two equations now. This is the first one and this is the second one. I will solve both of them, get their solution sets individually, or means union. So I will unite. I will take the union of their solution sets. That will be my final answer. Let's look at the first equation, okay? Very carefully. It says 2 minus sine x plus cos x is 0, which means 2 is equal to sine x minus cos x. Okay. Question is, what are the real values of x for which sine x minus cos x is 2? Are there any real values of x for which sine minus cos is 2? Tell me. It is something that you must know. You must know. See, if I write sine x minus cos x, what I'm going to do is I can multiply by root 2, divide by root 2. So I will get here root 2 and here root 2. Correct? Okay, now what? Yes. Now what? Just see, root 2 is here. Now I can write this one by root 2 as cos pi by 4 and this one by root 2 as sin pi by 4. So my bracketed expression now resembles sin a cos b minus cos a sin b, which is sin of a minus b, to sin of x minus pi by 4. Okay. So I had sin x minus cos x originally, which is equivalent to this very expression. Alright, what next? I know sine of any real angle is less than equal to 1, greater than equal to minus 1 for every real angle theta. That means sine of x minus pi by 4 for any real x also will be less than equal to 1, greater than equal to minus 1. If I multiply throughout by root 2, what will I get? Minus root 2 is less than equal to sine of x minus pi by 4 is less than equal to root 2. That means root 2 is the maximum value of sine of x minus pi by 4, which is exactly same as sine x minus cos x. What did we understand? Max value of sine x minus cos x is root 2, which is approximately 1.414. If sin x minus cos x can be at max root 2, nothing more than that, that means there is no possible real x for which sin x minus cos x can be greater than root 2. But this number 2 is greater than root 2. So this particular equation has no solution. Or the solution set corresponding to the first equation is the empty set phi. Similarly, look at the second equation as well. What does it say? What are the values of x for which minus sin x is equal to 2 and also cos x is equal to 2? Understand, cos x can never be equal to 2 because maximum value of cos is 1. Similarly, minus sin x being equal to 2 means sin x being equal to minus 2. But minimum value of sin is minus 1. There is no real x for which sin can produce values lesser than minus 1. That means there is no x for which sin x can be minus 2. So even this has no solution. So this complete equation again has no solution, or the solution set corresponding to second equation is phi. Once we have the solution sets corresponding to both the equations, in the end I told you we will take the union. So phi union phi obviously is nothing but phi. So phi is the answer. That means no value of x will satisfy the given equation. I hope you understood. Please keep this result very, very handy. It is super duper useful to accelerate the speed with which you are solving the question, because it really makes the solution very, very short and compact. Very, very smart approach to use this result, okay? Moving ahead to the next question, it says if k is 1 degree, then 2 sine 2k plus 4 sine 4k plus 6 sine 6k and so on till 180 sine 180k is equal to what? Okay, so if k is 1 degree, that means my given series is actually 2 sine 2 degree plus 4 sine 4 degree plus 6 sine 6 degree plus and so on 180 sine 180 degrees. Correct? Okay, but I know as a matter of fact that sine of 180 degrees is 0. 0 into 180 is 0. So last term is actually 0. This term is 0. So let me stop my series at the second last term. So you can see you have twice of sine 2, then 4 times sine 4, then 6 times sine 6. So second last term will be 178 times sine 178 degrees. Right? Let me remove this. 178 times sine of 178 degrees. So this is your series whose value you want to find out. The trick of the trade that we are going to use here is that I will reverse the series and add it up with this one, or subtract depending upon what I need. All you have to do is reverse the series and operate it with this particular series. Right? So the same series S I will write in ulta fashion, पीछे से आगे. So you will have 178 times sine 178 plus what will be the second last term here, 176 times sine 176. Then you will have 174 times sine 174 plus and so on. Last term will be 2 times sine 2 degrees. As I said, you can either add both these series or subtract depending upon the situation. Here we are going to prefer adding them because you can see that sine 178 is same as sine of 180 minus 2, isn't it? Sine of 180 minus 2. And sine of pi minus theta is same as sine theta, so this is same as sine 2. Correct? Did you understand? So sine 178 is actually same as sine 2. So when you add both these series, what are you going to get? Twice of sine 2 plus 178 times sine 2. That means 180 times sine 2 degrees. Similarly, sine 176 is same as sine 4. Sine 4. So what are you getting? 4 times sine 4 degrees plus 176 times sine 4 degrees. That means again 180 times sine of 4 degrees. Next, sine 174 is same as sine 6. Because 6 degrees and 174 degrees, they are supplementary angles. Right? And sine of pi minus theta is same as sine theta. So you are getting 6 times sine 6 degrees plus 174 times sine 6 degrees. That means 180 times sine of 6 degrees. And in the end, continuing with the same observation, you get sine 2 degrees to be exactly same as sine 178 degrees. So 178 plus 2 gives you 180. So you are going to get 180 times sine of 178 degrees. This is the value of 2s. So what is 2s coming out to be? 180 common. you have sine 2 degrees plus sine 4 degrees plus sine 6 degrees plus and so on sine 178 degrees. Now, can you tell me how many terms are sitting here in this series? Well, sine 2 degrees is the first term, sine 4 degrees is the second term, half of 4 is 2. Sine 6 degrees is half of 6, that is third term, and so on. Sine 178 will be half of 178, that means 89, so 89th term. So here in total there are 89 terms. And I will deliberately write the bracketed expression in another form for you. So sine 2 degrees, let it remain as it is, plus sine of 4 degrees I can write as 2 degrees plus 1 times 2 degree. Then sine of 6 degree will be sine of 2 degree plus 2 times 2 degree. Then sine of 8 degrees will be sine of 2 degree plus 3 times 2 degree. Plus and so on, last term will be sine of 2 degree plus 88 times 2 degree. Why did I rewrite my expression in this format? Because I want you to identify that over here inside the bracket you have the formation of sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta and so on. Can you see that? You have sine of alpha, alpha is 2 degrees, sine of alpha plus 1 times beta plus sine of alpha plus 2 times beta plus sine of alpha plus 3 times beta and so on, right? How many terms are there in total? N terms, right? N terms was 89 terms, so my N is 89. I know by the result that sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta and so on is given by sine of n times beta by 2 upon sine beta by 2 multiplied by sine of alpha plus n minus 1 by 2 times beta. Let's quickly apply this. So my alpha was 2 degrees, beta again 2 degrees, and number of terms we had already understood, 89. So my bracketed expression completely, which is this one, this complete bracketed expression, will dissolve to sine of n times beta by 2. So 89 into 2 degrees by 2 whole upon sine of beta by 2, 2 degree by 2, multiplied with sine of alpha, that is 2 degree, plus n minus 1 is 88 by 2 times beta, which is again 2 degrees. Okay, so 2 times 2 degree, basically 2 degree upon 2 is 1, so you are left with sine of 89 degrees upon sine of 1 degree into sine of, this is 44, 44 into 2 is 88, 88 plus 2 is 90, so sine 90 degrees. Sine 90 you know is 1. Sine 89 I will keep as it is, and sine 1 I can write as cos 89, do you agree? Because 89 and 1 are forming a pair of complementary angles and sine and cos are co-ratios, complementary trigonometric ratios. Sine 1 is same as sine of 90 minus 89, which is same as cos 89. And sine 89 upon cos 89 is nothing but tan 89. That means, now if I go back to this particular original expression, my 2s is coming out to be 180 times tan 89, divide by 2, you will get 90 times tan 89 degrees, and that's the value of S, which was my very original series that was given to us in the question. Alright, did you understand this question nicely? 90 times 89 degrees is the answer. Here 2 steps were extremely important. Number 1, we had to reverse the series and then add it to the original series. And number 2 was the result of sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta and so on. Correct? Both these things, keep it very, very handy. Here, B option is absolutely correct. Okay, moving ahead, we have this question. It says if A is tan 6 degrees into tan 42 degrees and B is cot 66 degrees times cot 78 degrees, then what is the relationship between A and B? Now, one approach could be to explicitly find what is angle A, explicitly find what is angle B, and then decode the relationship between them. But that's a very impractical approach because you can see the angles involved here are not standard angles, right? So we cannot actually compute what is tan 6 into tan 42 and what is cot 66 into cot 78 to get the values of A and B. So rather what we are going to do is we will work upon getting the ratio A by B, because you can see the first option is saying that A by B is 2. The second option says that A by B is 1 by 3. The third option says that A by B is 1, and the fourth option says that A by B is 2 by 3. So we are not going to actually fetch the values of A and B. We will rather work upon computing the value of A by B, and accordingly we will mark the right answer among the four options. So let's start. What is A by B? This should be simple. Tan 6 degrees into tan 42 degrees upon cot 66 degrees into cot 78 degrees. When theta is such that tan theta and cot theta both are non-zero, then for that theta, tan and cot are reciprocals of each other. Here 66 degrees, 78 degrees, both are acute angles. I know for an acute angle, every trigonometric ratio is positive. It's non-zero. That's why I can write cot 66 as 1 upon tan 66. So tan 66 will come up, and 1 upon cot 78 will be nothing but tan 78. So this is my A by B. Now I can see I have product of 4 tan terms, and this should immediately bring into mind the very result that tan theta into tan of 60 minus theta into tan of 60 plus theta is nothing but tan 3 theta. Here, if I consider my theta to be 6 degrees, okay, so my theta is 6 degrees. Now the result says that we should have 60 minus theta and 60 plus theta, correct? So 60 minus theta will be 60 minus 6, which is 54, and 60 plus theta should be 66. Now 66 I already have, but 54 I don't have. So what I'm going to do is I'm going to multiply and divide by tan 54. So I will get tan 54 degrees, then tan 6 degrees, then tan 66 degrees, all of this together. I'm left with tan 42 degrees, tan 78 degrees, and I should divide by tan 54. Right? So what is this? This is tan theta, tan 60 minus theta, tan 60 plus theta. This is same as tan of 3 theta. So 3 times 6 is 18. So 18 degrees. Next is tan 42 degrees. Next is tan 78 degrees upon tan 54 degrees. Again, let's do the same thing. If I consider 18 degrees to be theta, then 60 minus theta will be 42. And 60 plus theta, that means 60 plus 18 will be 78. So complete numerator is going to resolve to tan of 3 theta. That means 3 times 18 degrees, which is 54 degrees. And denominator already is tan 54 degrees. 54 degrees is an acute angle, so tan 54 will be positive, non-zero. So I can cancel it out. My answer is equal to 1. That's it. The answer is nothing but 1. So if I'm getting that A by B is 1, that means A is equal to B. This was quite an easy question. The first thing that you had to realize was that do not invest time, rather do not waste time in chasing the exact values of A and B. Instead of that, work upon computing the ratio A by B. Very first thing to keep in mind. And number 2 is whenever you find continuous product of the tan ratios such that the relationship between angles is like theta, 60 minus theta, 60 plus theta, then this is the result which should come into your mind immediately. Alrighty. Moving ahead to the next question, this one is asking us to compute the value of this very expression. Here, throughout the trigonometric ratios is the same, cos. But what is different is the angles, the arguments involved. Obviously, in order to simplify this expression, I have to somehow decode the relationship between the angles. So let's do that. I have cos of pi by 65, cos of 2 pi by 65, cos of 4 pi by 65, then 8 pi by 65, then 16 pi by 65, and then I have 32 pi by 65. You can clearly see that if I take pi by 65 as theta, my expression will look like cos theta, then cos 2 theta, then cos 2 square theta, and so on, cos 2 to the power 5 theta. Do you agree? This is 1 times pi by 65, so this completely is theta. Then 2 times pi by 65, 2 theta. 4 times pi by 65 means 2 square times theta. 8 times pi by 65 means 2 cube times theta. 16 times pi by 65 means 2 to the power 4 times theta. And 32 pi by 65 means 2 to the power 5 times theta. This is when you should immediately recollect the result that cos A into cos 2A into cos 2 square A and so on till cos 2 to the power n minus 1A is given by sine of 2 to the power n times A upon 2 to the power n times sine A. So here cos A is same as cos theta, cos 2A is same as cos 2 theta, cos 2 square A is same as cos 2 square theta, cos 2 cube A is same as cos 2 cube theta, cos 2 to the power 4A is same as cos 2 to the power 4 theta, and the last term matches. That means cos of 2 to the power n minus 1 times A is same as cos of 2 to the power 5 times theta, thereby implying that n minus 1 is 5 or n is 6. If n is 6, then my original given expression, this one will be equal to what? This will be equal to sine of 2 to the power 6 times angle A, that is theta over here, upon 2 to the power 6 times sine theta. All we have to do is simplify this expression to the maximum level possible, that's it. 2 to the power 6 is 64, so you get 64 theta. Theta is nothing but pi by 65. So 64 times pi by 65. Then you have 2 to the power 6 again, 64 and sine of pi by 65. But 64 times pi by 65 I can write as pi minus pi by 65. And sine of pi minus theta is same as sine theta. So you are left with sine of pi by 65 upon 64 times sine of pi by 65. This gets cancelled out. You are left with 1 by 64. Okay? 1 by 64 is the final value, and the trick or the hack that we have used to crack this question is this very result. Okay? Keep this in mind, store it in your head, and understand whenever you have questions like these, in the beginning we definitely think that okay, cosine ratio is throughout common, so I need to work upon generating some kind of a relationship between the angles. But when you actually observe, when you dig deep into what the angles are, you realize that what is happening? GP pattern is involved. You have 2 theta, then 2 square theta, then 2 cube theta, and so on. That's when this result comes into action and helps you reach the answer quickly. Alright folks, so with this it's a wrap. I hope you thoroughly enjoyed today's class and you did learn a lot from here. I am going to see you super soon. It's me, Bhumika, signing off. Take care and keep learning.